You ever walk into your house and know exactly what's for dinner before you even see it? You know that amazing smell that just hits you from all the way across the room? Well, today, we're going to solve the mystery of that traveling aroma using some pretty incredible science.
Just think about it for a second. When something's cooking, sizzling away on the stove, that delicious smell can reach you from, I don't know, several meters away. It makes your mouth water before you've even stepped into the kitchen. But then, what about cold food? Something straight out of the fridge. You have to get right up to it, practically stick your nose in it to get a whiff. So what's the deal? Why does heat send smells on this epic journey? Well, to crack this case, we need to get down to the basics. We have to understand the fundamental stuff that everything is made of, from that sizzling food to the very air its smell is traveling through. We, my friends, need to talk about matter.
Okay, let's get right into it. Matter, simply put, is just stuff. It's anything that has mass and takes up space. So, the air you're breathing right now, the food you eat, the clouds, distant stars, even a tiny drop of water. Yep, it's all matter.
Now for our first big clue. You see, for a very long time, scientists were kind of stumped about what matter was really like on the inside, and this led to a pretty huge debate. Was matter one solid, continuous thing, like a block of wood? Or was it made of a bunch of tiny individual bits, kind of like a pile of sand? Well, turns out the sand side was right, and a really simple experiment proved it. And this experiment is just brilliant. You take just a few tiny purple crystals of potassium permanganate and dissolve them. The water turns deep purple. Then you take a little bit of that colored water and dilute it again, and then you do it again and again. Even after doing this 8 times, the water is still faintly purple. This is amazing proof that those first few crystals must be made of millions and millions of tiny particles, each one spreading out through all that water. And the conclusion from this is just mind-blowing. These particles are so incredibly tiny, they are literally smaller than we can even imagine. So that's the first secret of matter. It's made of countless microscopic particles. So, okay, we know matter is made of particles. Awesome. But to solve our food smell mystery, we need to know how these particles actually act. And it all boils down to 3 simple but really powerful rules. These are the 3 fundamental laws that govern the entire particle world. So let's break them down one by one.
Rule number 1. There are actually gaps between particles. How do we know this? Well, if you take a beaker of water and you dissolve some salt in it, you'd totally expect the water level to rise, right? But it doesn't. That's because the tiny salt particles are just tucking themselves into the empty spaces that were already there between the water particles. How cool is that?
All right, rule number 2. And listen up, because this one is a huge clue for our mystery. Particles are never, ever still. They are constantly zipping around, vibrating, bumping into each other. This energy of motion has a name. It's called kinetic energy. And when these moving particles cause different things to mix all on their own, like a drop of ink spreading through water, we call that process diffusion.
So here's the absolute crucial point. When you add heat, you're giving those particles more energy, and they go wild. They move faster, they bash into each other more, and as a result, they diffuse much, much more quickly. This direct link between heat and particle speed, that is a massive clue. And our final rule, particles attract each other. There's this invisible force that's always pulling them together. It's kind of like these I Do Mish Me dancers locking arms to stay together in their formation. Some particles, like in a rock, hold on super tight. Others, like in the air, have a really, really weak grip on each other. So how do these 3 rules, the spaces, the constant motion, and the attraction, how do they play out in the real world? Well, they combine to create the 3 states of matter we see every single day: solids, liquids, and gases. This table just lays it all out perfectly. In a solid, that attraction force is super strong, so it holds particles in a fixed shape where they just kind of vibrate. In a liquid, the attraction is weaker, so particles can slide past each other, which is why a liquid takes the shape of its container. And in a gas, it's a total free-for-all. There's almost no attraction, so the particles have tons of energy and space, and they just fly around randomly at high speed, filling whatever container you put them in. All right, we have all our clues. We know matter is made of tiny particles, we know they're always moving, and we know heat makes them move way faster. It is time to solve the mystery of the sizzling food. Let's go back to that amazing smell wafting from the kitchen. We're about to connect all the dots. First things first, the heat from the stove gets transferred to the food. This is like a shot of espresso for those tiny aroma particles. It supercharges them, giving them a massive boost of kinetic energy. They start vibrating and moving way, way faster.
Now, with all that new energy, the aroma particles can actually overcome the forces that were holding them to the food. They break free. They literally escape into the air, changing their state and becoming a gas.
And what did we learn that gas particles do? They move randomly at super high speeds and they spread out. This is diffusion in action, right in your kitchen. These high-energy gas particles travel super fast through the air, mixing with it until, eventually, they find their way to your nose, even if you're meters away.
And there you have it. Boom! Mystery solved. The smell of hot food travels so far because heat gives those little aroma particles the energy they need to turn into a gas and diffuse really, really fast. The particles from cold food, they have very little kinetic energy, so they just stay put, and you have to go to them. And you know, this isn't just about food. This same exact principle explains why sweating cools you down. The most energetic, high-energy particles in the sweat on your skin absorb heat from your body. That gives them enough energy to escape as a vapor, a process we call evaporation. And as they leave, they take your body heat with them, which leaves your skin feeling cooler. It's brilliant. So we've seen that matter is this dynamic, amazing thing, constantly changing states based on energy. But that's all under kind of normal conditions. What happens if you push things to the absolute extremes? Like at the super high temperatures in the core of a star, or the super cold temperatures near absolute zero. Could matter exist in other, even stranger forms? Well, that's a question for another time.